Running the advanced contexts and dependency injection examples. This chapter describes in detail how to build and run several advanced examples that use 401. The examples are in the following directory: tut-install. Examples. To build and run the examples, you will do the following. Use NetBeans IDE or the Ant tool to compile, package, and deploy the example. Run the example in a web browser. Each example has a build.xml file that refers to files in the following directory: tut-install. Examples. BP project. See Chapter 2, using the tutorial examples, for basic information on installing, building, and running the examples. The following topics are addressed here: the encoder example, using alternatives; the producer methods example, using a producer method to choose a bean implementation; the producer fields example, using producer fields to generate resources; the bill payment example, using events and interceptors; the decorators example, decorating a bean; the encoder example, using alternatives. The encoder example shows how to use alternatives to choose between two beans at deployment time, as described in using alternatives. The example includes an interface and two implementations of it: a managed bean, a facelets page, and configuration files. The coder interface and implementations. The coder interface contains just one method, code string, that takes two arguments: a string, and an integer value that specifies how the letters in the string should be transposed. Public interface coder: public string code string s, int val. The interface has two implementation classes, coder-impl and test-coder-impl. The implementation of code string and coder-impl shifts the string argument forward in the alphabet by the number of letters specified in the second argument. Any characters that are not letters are left unchanged. This simple shift code is known as a Caesar cipher, for Julius Caesar, who reportedly used it to communicate with his generals. The implementation in test-coder-impl merely displays the values of the arguments. The test-coder-impl implementation is annotated. Alternative. Import javax. Enterprise. Inject. Alternative public class test-coder-impl implements coder public string code string s, int val. Return input string is +s plus shift value is +val. The beans.xml file for the encoder example contains an alternatives element for the test-coder-impl class, but by default the element is commented out: beans. Alternatives, class, encoder. Test-coder-impl. Class, alternatives, beans. This means that by default, the test-coder-impl class, annotated alternative, will not be used. Instead, the coder-impl class will be used. The encoder facelets page in the managed bean. The simple facelets page for the encoder example, index.xml, asks the user to type the string and integer values and passes them to the managed bean, coder bean, as coder bean. Input string encoder bean. Trans val, HTML XMLNS equal HTTP. W3. Org. 1999. XHTML XMLNS. Our equal HTTP. Java. Sun. Com. JSF. HTML. H. Head. Title. String encoder. Title. Link ref equal resources. CSS. Default. CSS rel equal style sheet type equal text. CSS. H. Head. H. Body. H2. String encoder. H2. P. Type a string and an integer, then click encode. P. Depending on which alternative is enabled, the coder bean will either display the argument values or return a string that shifts the letters in the original string by the value you specify. The value must be between 0 and 26. H. Form id equal encodite. H. Output label value equal type a string. For equal input string. H. Input text id equal input string value equal coder bean. Input string. H. Output label value equal type the number of letters to shift by. For equal transval H. Input text int equal transval value equal coder bean. Transval P. H. Command button value equal encode action equal coder bean. Encode string P. H. Output label value equal result. For equal output string H. Output text int equal output string value equal coder bean. Coded string style equal color blue. P. H. Command button value equal reset action equal coder bean. Reset P. H. Form H. Body HTML. When the user clicks the encode button, the page invokes the managed beans encode string method and displays the result, coder bean. Coded string, in blue. The page also has a reset button that clears the fields. The managed bean, coder bean, is a request scoped bean that declares its input and output properties. The transval property has 3 bean validation constraints that enforce limits on the integer value, so that if the user types an invalid value, a default error message appears on the facelets page. The bean also injects an instance of the coder interface, named request scope public class coder bean private string input string, private string coded string, max 26, min 0. Not null private int transval, inject coder. In addition to simple getter and setter methods for the 3 properties, the bean defines the encode string action method called by the facelets page. This method sets the coded string property to the value returned by a call to the code string method of the coder implementation. Public void encode string set coded string coder. Code string input string, transval. Finally, the bean defines the reset method to empty the fields of the facelets page. Public void reset set input string. Set transval 0. Building, packaging, deploying, and running the encoder example. You can build, package, deploy, and run the encoder application by using either NetBeans IDE or the Ant tool. To build, package, and deploy the encoder example using NetBeans IDE. From the File menu, choose Open Project. In the Open Project dialog, navigate to tut-install. Examples. D. Select the encoder folder. Select the Open as Main Project checkbox. Click Open Project. In the Projects tab, right-click the encoder project and select Deploy. To run the encoder example using NetBeans IDE. In a web browser, type the following URL. http localhost 8080 encoder. The string encoder page opens. Type a string and the number of letters to shift by, then click encode. The encoded string appears in blue on the result line. For example, if you type Java and 4, the result is NES. Now, edit the beans.xml file to enable the alternative implementation of coder. In the Projects tab, under the encoder project, expand the Web Pages node, then the WEB-INF node. Double-click the beans.xml file to open it. Remove the comment characters that surround the alternatives element, so that it looks like this. Alternatives, class, encoder. Test coder info. Class, alternatives. Save the file. Right-click the encoder project and select Deploy. In the web browser, retype the URL to show the string encoder page for the redeployed project. http localhost 8080 encoder. Type a string and the number of letters to shift by, then click encode. This time, the result line displays your arguments. For example, if you type Java and 4, the result is result. Input string is Java, shift value is 4 to build, package, and deploy the encoder example using Ant. In a terminal window, go to tut-install. Examples. D. Encoder. Type the following command. Ant. This command calls the default target, which builds and packages the application into a WAR file. Encoder. war located in the dist directory. Type the following command and deploy. To run the encoder example using it. In the web browser, type the following URL, http localhost 8080 encoder. The string encoder page opens. Type a string and the number of letters to shift by, then click encode. The encoded string appears in blue on the result line. For example, if you type Java and 4, the result is NES. Now, edit the beans.xml file to enable the alternative implementation of coder. In a text editor, open the following file, tut-install. Examples: D, encoder, WEB-INF, beans.xml. Remove the common characters that surround the alternatives element so that it looks like this. Alternatives, class, encoder, test coder impl, class, alternatives. Save and close the file. Type the following command and deploy. In the web browser, retype the URL to show the string encoder page for the redeployed project. http localhost 8080 encoder. Type a string and the number of letters to shift by, then click encode. This time, the result line displays your arguments. For example, if you type Java and 4, the result is result. Input string is Java, shift value is for the producer methods example, using a producer method to choose a bean implementation. The producer methods example shows how to use a producer method to choose between two beans at runtime, as described in using producer methods and fields. It is very similar to the encoder example described in the encoder example, using alternatives. The example includes the same interface and two implementations of it, a managed bean, a facelets page, and configuration files. It also contains a qualifier type. When you run it, you do not need to edit the beans.xml file and redeploy the application to change its behavior. Components of the producer methods example. The components of producer methods are very much like those for encoder, with some significant differences. Neither implementation of the coder bean is annotated. Alternative, and the beans.xml file does not contain an alternatives element. The facelets page and the managed bean, coder bean, have an additional property, coder type, that allows the user to specify at runtime which implementation to use. In addition, the managed bean has a producer method that selects the implementation using a qualifier type. Chosen. The bean declares two constants that specify whether the coder type is the test implementation or the implementation that actually shifts letters. Private final static int test equal 1, private final static int shift equal 2, private encoder type equal shift. Default value. The producer method, annotated with, produces and chosen as well as request scope so that it lasts only for the duration of a single request and response. Takes both implementations as arguments, then returns one or the other, based on the coder type supplied by the user. Produces. Chosen. Request scope public coder get coder. New test coder impl TCI. New coder impl CI switch coder type case test. Return TCI, case shift. Return CI, default. Return null. Finally, the managed bean ejects the chosen implementation, specifying the same qualifier as that returned by the producer method to resolve ambiguities. Inject. Chosen. Request scope coder. The facelets page contains modified instructions and a pair of radio buttons whose selected value is assigned to the property coder bean. Coder type. H2. String encoder. H2. P. Select test or shift, type a string and an integer, then click encode, P. If you select test, the test coder impl bean will display the argument values, P. If you select shift, the coder impl bean will return a string that shifts the letters in the original string by the value you specify. The value must be between 0 and 26. H. Form id equal encodite, H. Select 1 radio it equal coder type required equal true value equal coder bean. Coder type F. Select item value equal 1 item label equal test. F. Select item value equal 2 item label equal shift letters. H. Select 1 radio. Building, packaging, deploying, and running the producer methods example. You can build, package, deploy, and run the producer methods application by using either NetBeans IDE or the Ant tool. To build, package, and deploy the producer methods example using NetBeans IDE. From the File menu, choose Open Project. In the Open Project dialog, navigate to tut-install. Examples. D. Select the Producer Methods folder. Select the Open as Main Project checkbox. Click Open Project. In the Projects tab, right-click the Producer Methods project and select Deploy, to build, package, and deploy the Producer Methods example using it. In a terminal window, go to tut-install. Examples. D. Producer Methods. Type the following command. This command calls the default target, which builds and packages the application into a WAR file, producer methods. WAR, located in this directory. Type the following command, and deploy. To run the producer methods example. In a web browser, type the following URL, http localhost 8080 producer methods. The string encoder page opens. Select either the test or shift letters radio button, type a string and the number of letters to shift by, then click encode. Depending on your selection, the result line displays either the encoded string or the input values you specified. The producer fields example, using producer fields to generate resources. The producer fields example, which allows you to create a to-do list, shows how to use a producer field to generate objects that can then be managed by the container. This example generates an entity manager object, but resources such as JDBC connections and data sources can also be generated this way. The producer fields example is the simplest possible entity example. It also contains a qualifier and a class that generates the entity manager. It also contains a single entity, a stateful session bean, a facelets page, and a managed bean. The producer field for the producer fields example. The most important component of the producer fields example is the smallest, the DB. User Database Entity Manager class, which isolates the generation of the entity manager object so that it can easily be used by other components in the application. The class uses a producer field to inject an entity manager that is annotated with a user database qualifier, also defined in the DB package. Singleton public class user database entity manager produces persistence context. User database private entity manager M. The class does not explicitly produce a persistence unit field, but the application has a persistence XML file that specifies a persistence unit. The class is annotated javx. Inject. Singleton to specify that the injector should instantiate it only once. The DB User Database Entity Manager class also contains commented out code that uses create and close methods to generate and remove the producer field. Persistence Context Private Entity Manager M produces User Database Public Entity Manager create return M. Public void close disposes User Database Entity Manager MM close. You can remove the comments from this code and place them around the field declaration to test how the methods work. The behavior of the application is the same with either mechanism. The advantage of producing the entity manager in a separate class rather than simply injecting it into an enterprise bean is that the object can easily be reused in a type-passive way. Also, a more complex application may want to create multiple entity managers using multiple persistence units, and this mechanism isolates this code for easy maintenance, as in the following example. Singleton public class JRSource producer produces persistence unit name equal poo3. Test database entity manager factory customer database persistence unit produces Persistence context unit name equal poo3. Test database entity manager customer database persistence context, produces. Persistence unit name equal poo4. Documents entity manager factory customer database persistence unit, produces. Persistence context unit name equal poo4. Documents entity manager doc database entity manager. The entity manager factory declarations also allow applications to use an application managed entity manager, the producer fields entity and session bean. The producer fields example contains a simple entity class, entity, to do, and a stateful session bean, EJB, request bean, that uses it. The entity class contains 3 fields. An auto-generated id field, a string specifying the task, and a timestamp. The timestamp field, time created, is annotated with temporal, which is required for persistent date fields. Entity public class to do implements serializable private static final long serial version id equal 1L, id. Generated value strategy equal generation type. Auto private long id. Protected string task text, temporal timestamp protected date time created, public to do long id, string task text, date time created this. Id equal id, this. Task text equal task text, this. Time created equal time created. The remainder of the to-do class contains the usual getters, setters, and other entity methods. The request bean class injects the entity manager generated by the producer method, annotated with a user database qualifier, conversation scoped. Stateful public class request bean. Inject user database entity manager M. It then defines 2 methods, one that creates and persists a single to-do list item, and another that retrieves all the to-do items created so far by creating a query. Public to-do create to-do string input string to-do equal null, date current time equal calendar. Get instance. Get time. Try to-do equal new to-do. To-do. Set task text input string. To-do. Set time created current time. M. Persist to-do. Return to-do. Catch exception E throw new edge exception E. Get message. Public list. To do. Get to DOS try list. To do. To DOS equal list. To do. M. Create query select T from to do T order by T. Time created. Get result list. Return to DOS. Catch exception E throw new edge exception E. Get message. The producer fields facelets pages and managed bean. The producer fields example has 2 facelets pages, index, XHTML and tut-list. XHTML. The simple form on the index. XHTML page asks the user only for the task. When the user clicks the submit button, the list bean create task method is called. When the user clicks the show items button, the action specifies that the tut-list XHTML file should be displayed. H. Body. H2. To-do list. H2. P. Type a task to be completed. P. H. Form id equal tut-list. P. H. Output label value equal type a string. For equal input string. H. Input text id equal input string value equal list bean. Input string. P. H. Command button value equals submit action equal list bean. Create task. P. H. Command button value equals show items action equal tut-list. P. H. Form. H. Body. The managed bean. Web. List bean injects the EJB. Request bean session bean. It declares the entity. To do entity and a list of the entity, along with the input string that it passes to the session bean. The input string is annotated with a not null bean validation constraint, so that an attempt to submit an empty string results in an error. Named Conversation scope public class list bean implements serializable private static final long serial version INUID equal 1L. EJB private request bean request. Not no private string input string. Private to do. Private list. To dos. The create task method called by the submit button calls the create to do method of request bean. Public void create task this. To do equal request. Create to do input string. The get to dos method, which is called by the tut-list. XHTML page calls the get to dos method of request bean. Public list. To do. Get to dos return request. Get to dos. To force the facelets page to recognize an empty string as a null value and return an error, the WEB-XML file sets the context parameter javx. Faces. Interpret empty string submitted values as null to true. Context param name, javx. Faces. Interpret empty string submitted values as null. Param name, param value. True. Param value. Context param, the tut-list. XHTML page is a little more complicated than the index HTML page. It contains a data table element that displays the contents of the to-do list. The body of the page looks like this. Body, H2. To-do list, H2, H. Form id equal shall list, H. Data table var equal to do value equal list bean. To dos rules equal all border equal 1 cell padding equal 5, H. Column, F. Facet name equal header, H. Output text value equal timestamp, F. Facet, H. Output text value equal to do. Time created, H. Column, H. Column, F. Facet name equal header, H. Output text value equal task, F. Facet, H. Output text value equal to do. Task text, H. Column, H. Data table P, H. Command button id equal back value equal back action equal index, P, H. Form, body. The value of the data table is list bean. To dos, the list returned by the managed beans get to dos method, which in turn calls the session beans get to dos method. Each row of the table displays the time created and task text fields of the individual task. Finally, a back button returns the user to the index XHTML page. Building, packaging, deploying, and running the producerfields example. You can build, package, deploy, and run the producerfields application by using either NetBeans IDE or the Ant tool. To build, package, and deploy the producerfields example using NetBeans IDE. From the File menu, choose Open Project. In the Open Project dialog, navigate to tut-install. Examples. Select the producerfields folder. Select the Open as Main Project checkbox. Click Open Project. In the Projects tab, right-click the Producerfields project and select Deploy, to build, package, and deploy the Producerfields example using Ant. In a terminal window, go to tut-install. Examples. Producerfields. Type the following command. Ant. This command calls the default target, which builds and packages the application into a WAR file, Producerfields. War, located in this directory. Type the following command, and deploy. To run the Producerfields example. In a web browser, type the following URL, http localhost 8080 Producerfields. The Create To-Do List page opens. Type a string in the text field and click Submit. You can type additional strings and click Submit to create a task list with multiple items. Click the Show Items button. The to-do list page opens, showing the timestamp and text for each item you created. Click the back button to return to the Create To-Do List page. On this page, you can enter more items in the list. The bill payment example, using events and interceptors. The bill payment example shows how to use both events and interceptors. The example simulates paying an amount using a debit card or credit card. When the user chooses a payment method, the managed bean creates an appropriate event, supplies its payload, and fires it. A simple event listener handles the event using observer methods. The example also defines an interceptor that is set on a class and on two methods of another class, the payment event class. The event class, event. Payment event, is a simple bean class that contains a no-argument constructor. It also has its string method and getter and setter methods for the payload components. A string for the payment type, a big decimal for the payment amount, and a date for the timestamp. Public class payment event implements serializable private static final long serial version INID equal 1L, public string payment type, public big decimal value, public date data time, public payment event. Override public string to string return this. Payment type plus equal dollar plus this. Value. To string plus a plus this. Data time. To string. The event class is a simple bean that is instantiated by the managed bean using new and then populated. For this reason, the 401 container cannot intercept the creation of the bean, and hence it cannot allow interception of its getter and setter methods. The payment handler event listener. The event listener, payment handler, contains two observer methods, one for each of the two event types. Logged. Session scope public class payment handler implements serializable. Public void credit payment. Observes. Credit payment event logger. Log level. Info, payment handler, credit handler. 0, event. To string. Call a specific credit. Handler class. Public void debit payment. Observes. Debit payment event logger. Log level. Info, payment handler, debit handler. 0, event. To string. Call a specific debit. Handler class. Each observer method takes as an argument the event, annotated with. Observes and the qualifier for the type of payment. In a real application, the observer methods would pass the event information on to another component that would perform business logic on the payment. The qualifiers are defined in the payment package, described in the bill payment facelets pages in managed bean. Like payment event, the payment handler bean is annotated, logged, so that all its methods can be intercepted. The bill payment facelets pages in managed bean. The bill payment example contains two facelets pages, index, XHTML and a very simple response. XHTML. The body of index. XHTML looks like this. H. Body. H3. Bill payment options. H3. P. Type and amount. Select debit card or credit card, then click pay. P. H. Form. P. H. Output label value equal amount. Dollar for equal amt. H. Input text it equal amt value equal payment bean. Value required equal true required message equal an amount is required. Max length equal 15. P. H. Output label value equal options. For equal opt. H. Select one radio it equal opt value equal payment bean. Payment option. F. Select item it equal debit item label equal debit card item value equal 1. F. Select item it equal credit item label equal credit card item value equal 2. H. Select one radio P. H. Command button it equal submit value equal pay action equal payment bean. Pay. P. P. H. Command button value equal reset action equal payment bean. Reset. P. H. Form. H. Body. The input text field takes a payment amount, passed to payment bean. Value. Two radio buttons ask the user to select a debit card or credit card payment, passing the integer value to payment bean. Payment option. Finally, the pay command button's action is set to the method payment bean. pay, while the reset button's action is set to the payment bean. Reset method. The payment bean managed bean uses qualifiers to differentiate between the two kinds of payment event. Named Session Scope Public Class Payment Bean implements serializable inject credit event, payment event, credit event, inject debit event, payment event, debit event. The qualifiers credit and debit are defined in the payment package along with payment bean. Next, the payment bean defines the properties that it obtains from the facelets page and will pass on to the event. Public static final int debit equal 1, public static final int credit equal 2, private int payment option equal debit, digits integer equal 10, fraction equal 2, message equal invalid value, private big decimal value, private date data time. The payment option value is an integer passed in from the radio button component. The default value is debit. The value is a big decimal with a bean validation constraint that enforces a currency value with a maximum number of digits. The timestamp for the event, data time, is a date object that is initialized when the pay method is called. The pay method of the bean first sets the timestamp for this payment event. It then creates and populates the event payload, using the constructor for the payment event and calling the event's setter methods using the bean properties as arguments. It then fires the event. Log public string pay. This. Set data time calendar. Get instance. Get time. Switch payment option case debit. Payment event debit payload equal new payment event. Debit payload. Set payment type debit. Debit payload. Set value. Debit payload. Set data time. Debit event. Fire debit payload. Break. Case credit. Payment event credit payload equal new payment event. Credit payload. Set payment type credit. Credit payload. Set value. Credit payload. Set data time. Credit event. Fire credit payload. Break. Default. Logger. Severe invalid payment option. Return. Response. XHTML. The pay method returns the page to which the action is redirected. Response. XHTML. The payment bean class also contains a reset method that empties the value field on the index. XHTML page and sets the payment option to the default. Log public void reset set payment option debit. Set value big decimal 0. In this bean, only the pay and reset methods are intercepted. The response. XHTML page displays the amount paid. It uses a rendered expression to display the payment method. H. Body. H. Form. H2. Bill payment. Result. H2. H3. Amount paid with. H. Output text it equal debit value equal debit card. Rendered equal payment bean. Payment option EC1. H. Output text it equal credit value equal credit card. Rendered equal payment bean. Payment option EC2. H. Output text it equal result value equal payment bean. Value. F. Convert number type equal currency. H. Output text. H3. P. H. Command button it equal back value equal back action equal index. P. H. Form. H. Body. The logged interceptor class. The interceptor class, logged interceptor, and its interceptor binding, logged, are both defined in the interceptor package. The logged interceptor binding is defined as follows. Inherited. Interceptor binding. Retention runtime. Target method, type public. Interface logged. The logged interceptor class looks like this. Logged. Interceptor public class logged interceptor implements serializable private static final long serial version INUID equal 1L. Public logged interceptor. Around invoke public object log method entry invocation context throws exception system. Out. print on entering method, plus invocation context, get method, get name plus in class plus invocation context, get method, get declaring class, get name, return invocation context, proceed. The class is annotated with both the log and the interceptor annotations. The around invoke method, log method entry, takes the required invocation context argument and calls the required proceed method. When a method is intercepted, log method entry displays the name of the method being invoked as well as its class. To enable the interceptor, the beans.xml file defines it as follows. Interceptors, class, bill payment. Interceptor, logged interceptor. Class, interceptors. In this application, the payment event and payment handler classes are annotated. Logged, so that all the methods are intercepted. In payment bean, only the pay and reset methods are annotated. Logged, so only those methods are intercepted building, packaging, deploying, and running the bill payment example. You can build, package, deploy, and run the bill payment application by using either NetBeans IDE or the Ant tool. To build, package, and deploy the bill payment example using NetBeans IDE. From the File menu, choose Open Project. In the Open Project dialog, navigate to tut-install. Examples. D. Select the bill payment folder. Select the Open as Main Project checkbox. Click Open Project. In the Projects tab, right-click the bill payment project and select Deploy. To build, package, and deploy the bill payment example using Ant. In a terminal window, go to tut-install. Examples. D. Bill payment. Type the following command. Ant. This command calls the default target, which builds and packages the application into a WAR file, bill payment. War, located in the this directory. Type the following command, and deploy. To run the bill payment example. In a web browser, type the following URL, http localhost 8080. Bill payment. The bill payment options page opens. Type a value in the amount field. The amount can contain up to 10 digits and include up to 2 decimal places. For example, 9876.54. Select debit card or credit card and click Pay. The bill payment result page opens, displaying the amount paid and the method of payment. Amount paid with credit card: $9,876.34. Optional, click back to return to the bill payment options page. You can also click Reset to return to the initial page values. Examine the server log output. In NetBeans IDE, the output is visible in the Glassfish Server 3.1 output window. Otherwise, view domain dir. Logs. Server. Log. The output from each interceptor appears in the log, followed by the additional logger output defined by the constructor and methods. Info. Entering method. Pay in class bill payment. Payment. Payment bean info. Payment handler created. Info. Payment handler created. Info. Payment handler created. Info. Entering method. Debit payment in class bill payment. Listener. Payment handler info. Payment handler. Debit handler. Debit equal $1,234.56 Tuesday, December 14th, 14:50. 28S 2010. The decorators example. Decorating a bean. The decorators example, which is yet another variation on the encoder example, shows how to use a decorator to implement additional business logic for a bean. Instead of having the user choose between two alternative implementations of an interface at deployment time or runtime, a decorator adds some additional logic to a single implementation of the interface. The example includes an interface, an implementation of it, a decorator, an interceptor, a managed bean, a facelets page, and configuration files, components of the decorator's example. The decorator's example is very similar to the encoder example described in the encoder example, using alternatives. instead of providing two implementations of the coder interface. However, this example provides only the coder-info class. The decorator class, coder decorator, instead of simply returning the coded string, displays the input and output strings values and length. The coder decorator class, like coder-info, implements the business method of the coder interface, code string. Decorator public abstract class coder decorator implements coder. Inject. Delegate. Any coder public string code string s, int valid len equal s. Length. Return. Plus s plus semicolon becomes plus. Plus coder. Code string s, val plus semicolon, plus len plus characters in length. The decorator's code string method calls the delegate object's code string method to perform the actual encoding. The decorator's example includes the logged interceptor binding and logged interceptor class from the billpayment example. For this example, the interceptor is set on the coder bean. Encode string method in the coder info. Code string method. The interceptor code is unchanged. Interceptors are usually reusable for different applications, except for the interceptor annotations. The coder bean and coder info classes are identical to the versions in the encoder example. The beans.xml file specifies both the decorator and the interceptor. Decorators, class, decorators. Coder decorator, class, decorators. Interceptors, class, decorators. Logged interceptor, class, interceptors. Building, packaging, deploying, and running the decorator's example. You can build, package, deploy, and run the decorator's application by using either NetBeans IDE or the Ant tool. To build, package, and deploy the decorator's example using NetBeans IDE. From the File menu, choose Open Project. In the Open Project dialog, navigate to tut-install. Examples. D. Select the decorators folder. Select the Open as Main Project checkbox. Click Open Project. In the Projects tab, right-click the decorators project and select Deploy. To build, package, and deploy the decorators example using it. In a terminal window, go to tut-install. Examples. D. Decorators. Type the following command and this command calls the default target, which builds and packages the application into a WAR file. Decorators. War, located in the dist directory. Type the following command and deploy. To run the decorators example. In a web browser, type the following URL, http localhost 8080 decorators. The bill payment options page opens. Type a string and the number of letters to shift by, then click encode. The output from the decorator method appears in blue on the result line. For example, if you type Java and 4, you would see the following. Java becomes NES, 4 characters in length. Examine the server log output. In NetBeans IDE, the output is visible in the Glassfish Server 3. 1 output window. Otherwise, view domain dir. Logs. Server. Log. The output from the interceptors appears. Info, entering method. Encode string in class decorators. Coder bean info, entering method. Code string in class decorators. Coder info.